Hi, I'm Alexandra Bates, and this is my interactive advanced concept video on nuclear arms. First, I'm going to start off by talking about nuclear arms, specifically atomic bombs. And nuclear arms are weapons of mass destruction, and they use nuclear energy to create an explosion. This energy is contained in atomic nuclei and is released in nuclear reactions and radioactive decay. With atomic bombs, to get a nuclear explosion to occur, a certain reaction must take place. The change of reaction of fission of heavy nuclei must occur. The most common element that is utilized is uranium-235, and uranium-235 is an isotope. Isotopes are different types of one element. To obtain a maximum amount of energy necessary during the explosion of an atomic bomb, the content of uranium-235 isotope needs to be at least 80%, meaning that uranium is further enriched. In these bombs, the nuclear explosion occurs because a certain mass of fissile material is concentrated in one area, and this is known as critical mass. When a critical mass is reached, a nuclear decay reaction is formed with the release of energy. However, for a powerful explosion, one critical mass is not sufficient enough, and we need more critical mass to make a more deadly reaction occur. So for a more powerful explosion, we need more than one critical mass because it's not sufficient enough. To make a bomb destructive enough, we need about 4 to 5 critical masses of matter that are needed. And this can be achieved in a variety of ways, but the most common way is the implosive method. And I'm going to talk about nuclear fission in just a second, but in the implosive method, the bomb has all of the necessary materials for the nuclear reaction inside of it, but the critical mass has not been reached. So in order to achieve the critical mass, a guided explosion from the outside will be created. First, I'm going to talk about nuclear fission, which is what we need to create these reactions in these atomic bombs. And nuclear fission produces a large amount of energy via the splitting of nuclei of large atoms. And there's a little visual aid here to the left. When the nucleus splits, this releases energy and neutrons. And then when the released neutrons restart the process with ever heavier nuclei, which then creates a chain reaction. So we can see the neutron and atomic nucleus are here, and then this splits into the nuclei, and when they split, this produces a large amount of energy because of the splitting of these nuclei. And it releases energy and neutrons as well, which you can see here. We have neutrons and energy being released, and then these released neutrons restart the process here again. And this then creates a chain reaction, which allows us to make this energy in an atomic bomb. So, as I was saying about implosive destruction, implosive destruction is the most common way that critical mass can be achieved. And in this scenario, a bomb has all the necessary materials, which I said before, for the nuclear reaction, but the critical mass has not been reached. So in order to achieve that, a guided reaction needs to occur. And when this guided reaction occurs, the guided explosion from the outside will be created. And the explosion may be placed on the outside of the bomb and then detonated. When the bomb is properly exposed, the space inside the bomb then shrinks inwards towards the center of the shock wave, and hence the density of uranium or plutonium, whatever's inside the bomb, will increase and a nuclear explosion will occur. Next, we're going to talk about hydrogen bombs. With hydrogen bombs, energy is released due to thermonuclear fission. A quick explosive reaction will take place inside the charge with the help from elements like deuterium and tritium and other heavier elements that can also be added to those as well. And the main effective substance in this scenario is lithium hydride, which by itself does not produce an explosion, which is important to note because this substance needs to be reacted inside the bomb itself via a device, an integrated nuclear device with low power, which is also known as detonators. And when it's activated, the energy inside is released via a trigger from the explosive thermonuclear reaction that builds inside the bomb. And it's also important to note that hydrogen bombs have no limit to their power potential. Nuclear weapons are measured in TNT equivalent, and TNT is an explosive. In terms of the power necessary for a nuclear explosion to occur, a certain amount of TNT is needed to produce the same energy. These bombs cause chaos and destructiveness due to shock waves and light radiation. Radiation is one of the factors caused as a result of the explosion of nuclear weapons. The three main types of ionizing radiation are alpha, beta, and gamma radiation, which I'm now going to cover. And with alpha radiation, these waves don't do as much harm, and they may be avoided via an individual's clothing. As you can see here, here's a little visual, and it's not able to penetrate through paper from this. And then our next type is beta radiation, which is more serious, and it can cause significant damage at a distance meters or feet from the radiation source. And some of its consequences include radiation burn and cataracts. As you can see, here's the visual, which it does penetrate through paper, but it is not able to penetrate through aluminum. So gamma radiation is what's next. Gamma radiation is very serious. This is the most serious type that can occur because of these type of reactions. It can only be avoided via thick layers of specific substances such as lead and concrete, and has a high penetration power. And because of this high penetration power, it permeates the body, causing damage such as radiation sickness, cancer, or gene mutations. And as you can see in this visual here, it's not able to get through the substances such as lead, and it's not able to penetrate through that, but it is able to penetrate through the body and through aluminum as well as paper. Well, thank you for listening to my interactive advanced video presentation. Have a great week.